international conference. I will talk about the selection and design of the air conditioning system in the facilities for patterning peak production depending on the conditions of thermal comfort. We focus on hot climate. Actually, this research was conducted in the Aarhus University of Denmark, but this section, focus on hot climate, is related to the production because it's in this actual project the investor wants to establish the large production in the region of Thailand, so where we have the hot climate. So as we all know that thermal comfort is, especially here when it comes to the animal production, is very important. So I will not go to these statements. I will just say, for example, for the concrete example for the pig production, if we ensure the adequate environment conditions, pigs can prosper and develop like 30 to 40% better. For example, the expected growth rate per day is 600 grams, and if we ensure the adequate environment conditions, we can achieve 900 grams per day. So what we are talking here is, actually it's funny, but we are trying to make sure that pigs are having a quite good life before they are slaughtered. So this production for the one stage is lasting for 3 months and is shown here on the diagram. So when we have a bird mean and the weights in the range of almost 15 or 7 kilos to more than 90 or in most cases 110 kilos. So here are the main boundaries within we need to control the temperature of the environment. So the upper boundary is the upper critical temperature, and the lower boundary is the lower critical temperature. This is very important because we need to feed the animals. So if they are feeling cold, energy intake which was taken through food is used to maintain the system. So we are actually not having the production, so we are not having the mass gain, so this is bad. On contrary, if we have the situation where the animals are experiencing the upper critical temperatures, they won't take feed, so they are losing their mass, they cannot prosper and develop, and there is a high risk of the heat stress. So there are some interesting things with thermal comfort and animals. With humans it's much more easier, although we are talking about thermal comfort, and thermal comfort is highly subjective. Someone already mentioned that we cannot measure it easily. So this is the statement that is highly subjective also for animals. For example, pigs don't sweat. Pigs cannot tell us if they are feeling comfortable or not. So we need to determine, so we need to pay attention on their behavior. There are also some recommendations. So the development of pigs is expressed here through weight. So this all happens in the period of the first day of their birth to the maybe 3 or 4 months. What is very interesting to say and to pay attention, so yes, you can see from the picture on the right side, pigs are losing heat through radiation, conduction to floor, and latent heat. This is all caused by non-adequate thermal comfort conditions. The biggest attention should be paid to floor, because according to the studies from 30 or 40 years from now back. We are having, it is already known that pigs are spending most of their time lying down. So if it's too cold, we will have the conduction to floor. Pigs will lose their heat. We need to feed them, and on the huge amount of numbers, it is calculated that per 1 day we can spend 1.4 euro just for the food for animals. So if you have more thousands, or maybe even a million, for example, in Denmark, there is more pigs than people. This is a huge amount of money, which can be avoided, and especially it's wanted by the investors and the big producers. So these are some recommendations regarding the pig weight and also age. What should be the floor type and which are the recommended temperatures. Also, it is important to mention the air quality, but we all know that. Especially here, because we have the high concentration of gases and level of dust. So air velocity here, minimum is recommended to be 0.2, but actually it's not present anywhere in the big production systems. It goes even above this 1 meter per second when necessary, so when it's really hot. Also, pigs accept the wide range of humidity. It is important to control the humidity and keep it in the shown range, because dry environment affects the nasal mucosa of the pig, while the wet environment pathogens might occur due to the droplet. Also, similarly to the humans, we have the metabolic rate also plays an important role in determination how animal is feeling. So as I already mentioned, 75 to 85% pigs are lying down, 5 to 10% they're eating, and remain of their time they're spent walking, sitting, rooting, and etc. So it is important also the real danger is when the temperature is greater than 30 degrees, and if the deep body temperature of the animal reaches 43 degrees, animals dies from the heart failure. Also, if the animal is starting to experience the heat stress, it is losing its latent heat through panting. And also we need to energy obtained through food. We are losing it to maintain the system in the normal operation of the animal. So one typical air conditioning systems which are now currently existing in the pig production are mainly air-based and water-based, while most of them involve some kind of evaporative cooling, which we analyzed in this research. Also, the present are cross-flow ventilation, tunnel ventilation, and in the terms of the evaporative cooling, we have the directly wetting animals, we have fogging systems, and evaporative cooling pads. Also, the refrigeration cooling, classical refrigeration cooling, is used only in the bore studs. So we here analyzed some of the most commonly used systems, which are sprinkling and dripping. So we are actually wetting the animal, and then we are moving air above, so we have the evaporation. This system is it's not quite cost. It doesn't have a big operating cost. It's simple to apply. Energy consumption is low, and reliability of the system in operation is quite good. Similarly, we did the same analysis for the other systems, but we needed to give the priority using the Promet T2 analysis we need to do priority for the system which are not, the main priorities are the costs. Initial cost and operating cost, because we need to have in mind that we are not talking about humans, we are talking about animals. Not that animals are less important, but humans should be, because humans are designing this system. So in this field of preferences, you can see the criteria called weight. So it is based on the subjective feeling of the experts. So the priority was given to the capital and operating costs. Energy consumption is here was not so big priority, because most often it goes into the operational costs. So these systems were analyzed, and we had some alternatives and criteria. Used the software Prometheus 2, which analyzed every criteria with every alternative and vice versa. So then we get the list of overall preference factors, and according to this analysis, evaporative cooling pads are the best solution for this system. Then we analyzed the system, air conditioning system with evaporative cooling pads. So as you may know, we have in psychometric process, dry air is considered as a single gas. So humid air is a mixture of two gases, dry air and water vapor. And the heat transfer will occur between rigid media cellulose or evaporative cooling pad, wet surface, and humid air flow close to wet surface. What it is the problem here? The problems are not the sensible and latent heat, but the problem is the variable wet surface temperature. So it makes it hard to calculate and analyze this. So we adopted, and we are now setting up experiments for the solution introduced by the two scientists, Dodi and Karbash. They presented a set of equations for heat and mass transfer coefficients associated with evaporative process in evaporative cooling pad from rigid media cellulose. And because there are a lot of equations, they are only put it like this in form of one algorithm. So as an input we have the inlet air conditions, water to air mass flow ratio, the characteristics of the evaporative cooling pad, and the number of segments in it. We are doing calculation for the first segment. In the first step, we are assuming or determining air properties, which can be measured or assumed. We are calculating the number of transfer units and coefficients introduced in this coefficients in this term alpha, which is introduced by the two scientists. They introduced alpha, beta, and phi. You can find them also in the nomenclature and in the paper. From the second step, we are computing beta and evaluating the water temperature at the outlet. We are computing phi and eta 1 from equation 9 to 10, also presented in the paper, and etc. We have the if part. So if we are getting that n is equal n plus 1, or that the temperature of the water at the outlet is equal to the temperature of water at the inlet, something is not right, or the system is not functioning. We need to do the measurements again, or to do the another set of iterations, or to determine another air properties, and if we getting that the n is bigger than the number of segments, we can calculate the average exit temperature, dry bulb temperature of the air, we can get the average humidity ratio, and we can get the exit and the temperature of the water at the exit. So practically, this is it. I don't have any conclusions. We adopted this method, and we are now investigating it. So we are setting the experiments back in our Arcus. So this is practically it. So if you have any questions and if we have time, I'm here.